Okay, another example of triangle similarity. In other words, we're going to try to prove in each one of these three cases whether the triangle is similar or not similar, and we're going to give a reason for it. So what I want to do to set this up is label my sides and my angles in these triangles. And we'll start with this first one. Side, side, angle, side, side, angle. Well, from that, I can see pretty clearly that this is not an angle, angle, angle situation, and it's not a side, side, side situation, because I'm only given one angle and two sides. So now it's a choice between similar or not similar by SAS. In other words, two sides with an angle in between them. And the way we do this is we examine two things. First of all, are the angles equal? That angle and this angle? Yes, they are. Next, and there's only one more test left to this, I take the short side of this triangle on the left. So I'm going to start over here. I'm going to look at that triangle on the left, and I'm going to take its short side and say, okay, that's 12. And I'm going to divide it by the short side of the triangle on the right, which is 6. And I'm going to ask myself, is that equal to 16 over 8? Okay, question mark. So if that's true, that statement that I just made, then these triangles are similar. If that's false, if 12 over 6 is not equal to 16 over 8, then they're not similar. So reduce these things, and you get 2 equals 2. Yeah, that sounds pretty good to me. So what that means is this is similar by SAS. So let's take a look at the next one. Similar pattern. I'm going to label it and say, okay, that's angles, and here's some other angles. And right away, since there's no sides, I know this is not going to be SAS, and it's not going to be SSS. It's something involving the AAA theorem, AAA. The problem is those angles don't look equal at first. It looks like there's going to be a little work involved here. And the key is, what is that missing angle right there? Okay, that missing angle in each of these. I think that's important. So what we're going to do is we're going to use our good old angles add up to 180 trick. Okay, let me make a little line here for new work. So I have 48 plus 39 plus, let's call it x. Okay, I think x is a better thing to label this. I'm going to say that angle right there is x. So the sum of those three angles equals 180. Well, little calculator work. And this looks like 87 on the left plus x equals 180. And now I'm going to balance the equation by getting x by itself. I'm going to subtract 87 from both sides. So in that case, x equals, looks like 93 degrees. Okay, great. So now I can replace x with 93 degrees. Okay, and we could do the same operation for the other one, which is 39 plus 92 plus, let's label this thing x over here, plus x equals 180. And now 39 plus 92, well, that's 131, I think, 131 plus x equals 180. And when I subtract that from both sides, I get x equals 49. Okay, so let's put that in our diagram. 49 degrees right here. Now, are these triangles three equal angles? And if you compare them, you'll see they got really close, but they are not similar. They don't have three equal angles. In other words, you can see this different angle right here. This one's 93, this one's 92. So that's our giveaway. Okay, last one. So on this bottom set of triangles, you see there's three sides, right? I've got side, 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 and I do not have any angles. So I know it's not going to be any of these theorems involving angles. What we're going to do is set up our equation where I take the shortest side on the left and compare it to the shortest side on the right. So that's 15 over 5. And then I'm going to take my medium side on the left. It's a little weird that they're the same. So 18 over 6. And then I'm going to take the largest sides of each one. So that's 18 on the left and 7 on the right. Well, you can use a calculator and figure out what these are, but I think in this case, there's a giveaway. Something should be looking a little bit dodgy. This thing right here. 18 over 6, we know that's not equal to 18 over 7. I'm not exactly sure what 18 over 7 is, but I know that's not similar. Okay, because if this was going to be similar, I would need all three of those fractions to be exactly equal.